How is everyone? Welcome to this video. Um, my name is Francis de Montalbocano. I belong into social mechatronic cover. This video is about the course networking and communication protocols. Okay, I'll take soup. Um, I'm going to analyze some characteristics of the TCP protocol. Okay, to do obviously we cannot study all in this single video. Okay, let's start. What is TCP protocol? TCP is transmission control protocol. Okay. Now, um, general features. This protocol, okay, works on the transport layer, exactly layer 3 on the TCP/IP model. On the model OSI works on the layer on the layer 4 with the same name, the transport layer. Okay. Now we need to remember some concepts of the network. Okay. To begin, we need to understand how the information is sent. Okay. From sending host to receiving host. In the application layer, the data is generated. Okay, and the data, okay, is generated in this part. Um, Now, the data, okay, need to encapsulate to transport at the next layer, the transport layer. Okay, and this part in the transport layer, the data is added of piece information called a header, in this case TCP header. Okay, all grouping receive the denomination of segment. So all this information is segment. Now the segment is sent, is delivered the internet layer here. Okay, of this piece of information, okay, added the EP header. Okay, now the internet layer, okay, deliver the next layer the data link through a dead other piece information, a header and a trailer. Okay. The name of this grouping here is packet. Okay, packet. Here, all this group is the frame. The frame Ethernet, okay, is delivered a physical network layer. Okay. So, this is the picture with the process. Okay. The user data, the piece of information is the TCP header. The TCP header with application data receive the name segment. Next, the deliver the data link with the EP header, and the ultimate path is they deliver this frame the physical layer. Okay. Now this is the encapsulation in the encapsulation overview. Okay. Now a communication overview on a TCP protocol. Okay, the TCP protocol help with uh, reliability, and the TCP protocol is the protocol of connection. Why? Okay, for example, we have a computer and we have a server. Okay, the computer sent a message to server. The message, the message. But in the middle, I don't know. We don't know what is in the middle. Can be that the network is is bad, because have problems, okay, with congest, or perhaps problem connection physical. So how can to have the security of the information was received is a good question. And this part, the TCP protocol have important function. Okay, why? Because the TCP protocol, okay, to um, mechanism help the that the information no will be lost. Okay, these mechanisms, the mechanism reliability is the positive acknowledgement and retransmission, or PAR. Okay, this is the example. No, we have a message, but with this mechanism, we have a confirmation and receive called ACK. How function? Okay, the message is sent to server, from computer to server. Okay, if the message was lost, okay, the server never back send the confirmation, a message of confirmation. So if the message is received um, for server, then the server sent a message with a confirmation. Now, how long time need to wait the computer for the confirmation? It's a good question. Okay, it's a good question. Okay, we have this example. When the computer sent the message, okay, before we need um, to connect to call. So computer call server. Okay, when the computer send the message in the same time, um, there is a timer start. Okay. This is my timer start. So with the message sent, my timer is start. Okay. When the server received the message, the timer, okay, um, um, continue with the time. But when the server send the confirmation, and the confirmation is received for the computer, the timer stop. is a good mechanism, okay? But there is a problem. In this example, the message was lost in the sport, but a time continually, but a timer continually with the time. For a time, the timer is continually, but when the computer not receive the message, okay, the timer is stopped, and the timer, the computer know that need to send um, again the message. In this example, the timer finished and the computer sent the same message. In this case, the message once was sent. So the server received the message and sent the confirmation ACK. Okay, was good, great. Other case, other case. Um, when we have the message, okay, but the message um, continually travel, but for the conquest, excuse me, is slow, is very slow. So the computer thought that the message was lost, but no, it's true. The message continually traveling. Then the computer sent the same message one, but for a time the message one here and the message one here were received for the server. Oh, what happened? Now we have two messages, the same message. In other words, we have a duplicate message. For this problem, the TCP protocol use the number, okay, number condition. The message one have a number 18, and this message have the number 75. With the numbers condition, we have the same message but with different numbers. In this case, the server recognize a duplicate and send the message of confirmation. The computer received this confirmation and recognized that there was a duplicate, and the buffer of the computer was is eliminate this message. Okay, this is the solution with the problem of duplicate. Okay, now okay, general mechanism window. This mechanism window is to accelerate the transmission of the data. For example, in this part, the computer send the message, but send 1, 2, 3, 4 message. Okay, send for message. When the message 1, the message 10 in this case, is received for the server to send the confirmation ECQ of the message 10 in this case. When the computer receives the confirmation of the message 10, to begin to send the message 14, and this process repeat when the computer receives the confirmation of each message. Okay, of this manner we can to accelerate that process. Okay. Now, what is the header TCP? Why is important on the process, on the transmission of the information? It's important because when the computer send the information, okay, the TCP header, okay, have these parts. Have port source number, the destination port number. The source port is the region port. The sequence number now is for a duplicate message. Okay. Now TCP ports. For example, the application that runs on a computer is called a process. Okay. We have three processes: application 1, application 2, application 3 was runs in the same time. So we have three processes. The application 1, for example, is HTTP. In other words, it's a web process. Application 2 is the send information, okay, download, okay. This is the FTP process, and application 3 is Gmail. Okay, it's my Gmail, so it's an email process. Okay. Now the application 1 generate the information that is different of the application 2 of the application 3. So the process 1 generate these segments. Okay. The application 2 generate this segment, and application 3 generate this segment. How is possible the server can to read the information and understand it? It's possible because the TCP have ports. Okay, have ports. These ports is the port's origin in the port's server. The port's origin are classified in three ports: 0, 1023 are the system ports. The 1024 and 99.105.1 are the user ports, and the rest are the free ports. The first part of the system ports are popular. Okay, for example, okay, The HTTP is have a number of port 18. So this is the number for origin, and this information is here. This information is here. Okay, the TCP header have a port origin 18. And this information is sent a server, and the server read the information, and the server understand the process is HTTP and understand that is the web process. Next part is send of the web process server the segment, and the segment port origin. For example, the server port is, I don't know, 162. Okay. Okay. The same for the other ports. The user port, for example, the Spotify have a number port. I don't know what is the number port. I believe this is, and I don't know, 245. I don't know. So this process was received to TCP header. A TCP header have the port origin, and the port origin have a name. The name of Spotify is this. The segment, the frame is sent. The server read the TCP header. The TCP header have this name, so the server read this number and recognize what is the process. The process is that. Okay. So this is all. Okay, this is all. I hope that the information was clear. It is my first time to do the video and to talk in English. Sorry. Okay, this is all. Um, this is all of my part.